Hello and welcome to this Bentley Success Factors webinar on reverse engineering in MAXSURF by Dr. Pat Couser. In part 1 of this webinar we looked at the various common data sources and how these can be used in MAXSURF. We also looked at how these data should be processed as a precursor to generating vessel models in MAXSURF. In particular, we focused on the workflow for creating tri-mesh models. Now in part 2 of this webinar we will look at creating NURB surface models using the imported reference data. The NURB surface models are particularly useful if we want to modify the models or if we want to generate parts for production. We shall now look at how to create a NURB surface model of an existing vessel. A NURBS model should be used when you require a smooth, faired vessel model. This is typically the case if you intend to modify the model or generate parts for production, for example plates, frames, etc. We shall review some of the prerequisites that are required, as well as some of the common setup. Finally, we shall look at the different NURBS fitting workflows and the relevant tools available in MAXSURF. Here are some of the prerequisites you should review before attempting to generate your model. Firstly, you should be familiar with MAXSURF Modeler. You should already know how you would go about creating a model of the vessel, the number of surfaces, their topology and layout, and if necessary, where surfaces should be bonded together and where they should be trimmed. You should also consider the number of control points that would be required and surface stiffnesses in both longitudinal and transverse directions. The markers are just an additional constraint to be used as a check that the NURBS surface model matches the original vessel. Secondly, consider the accuracy of the markers. Do you need to have an exact fit of the markers or will an approximation suffice? Do the markers have any noise or error, in which case the NURBS surfaces should smooth through the marker points. If the data comes from a digital lines plan of a faired vessel, then the markers probably lie on a hull surface exactly, and the goal will be to have the NURBS surfaces pass exactly through the markers. If, on the other hand, the markers come from a manually digitized lines plan, there is likely to be some error, and we should be aiming for a fair NURBS surface that approximates the markers. The marker setup for NURBS surface modeling is essentially the same as we did for the tri-mesh generation. Basically, delete any duplicates that lie within a certain tolerance, and if the markers are structured, then define the section grid, especially stations, according to the marker locations. And although not strictly necessary, it often helps to ensure that the markers are ordered correctly on each section. Marker order is used for some of the commands, but the genetic algorithm fitting is designed to work equally well with an unstructured point cloud. So for all the NURBS fitting workflows, there is some common setup that we should follow. As discussed previously, set up the markers correctly, then we can start adding surfaces to the model. It is normally best to fit one surface at a time, so it can be convenient to add a dummy surface which can be used to hide all the markers that we are not currently interested in. Markers follow the visibility of the surface they are assigned to, so hiding the dummy surface and assigning the markers we wish to hide to this dummy surface will hide them. Add control points and adjust the surface stiffness so the required features can be modelled. Manually fitting surfaces to markers is, in many cases, very time efficient, as humans are actually pretty effective. Also, if you are new to the MAXSURF fitting tools, manually fitting surfaces is a good starting point because it gives you a good feel for what shapes can be achieved with a NURB surface. Remember that the fitting tools can only assist you and speed up your workflow, but they won't magically make your NURB surface fit your markers if it wouldn't be possible to achieve the same surface shape by manually manipulating the control points. A NURB surface's corners lie exactly on the corner control points, so start by fitting the corners. Then fit the surface edges because the surface edges are unaffected by the interior control points. Finally, adjust the interior control points to fit the rest of the surface to the markers. We can now see how we'll fit a surface manually. So the first thing to do is just add a default surface, and we can fit the corner points numerically and start fitting the edges. So I've jumped a few steps here, I've added some control points and I'm fitting the top edge to the shear line. Just using the drawing as a guide for the moment. some points are on the centre line, so I'll edit those manually, and then I'll just drag these to roughly the right location. Then I can zoom in and make any finer adjustments. A particularly tricky area of this boat is the stern, and this point actually needs to be right at the same longitudinal position as the centerline point, so that we get a nice smooth curve going into the centerline. So I'll edit that manually to 15 meters and increase the precision so I get a smoother curve. So I can see here I haven't really got enough control points in this area to get the right shape, so I'm going to go back to the profile view and add an extra control point column there. So now when I'm back in the profile view, I'm not changing the longitudinal position, just the offset there, so that won't affect the shear line in any way. So there I've got quite a good match to this shear line in the stern. We can have a look at getting the transom fitted. This is a bit of an awkward shape here because there's quite a lot of change of shape and also a chine at the top there. So to model the chine I'm going to use compacted control points, so I need to go to the body plan view to add some extra control point rows. And what I'll actually do is change the stiffness to 3, which means I just need to compact 2 control points, and that will give me a knuckle that I can fade out. So that's the knuckle I need to model, so I'll select these 2 control points and use the compact and then group them together so they both move together. So that will model the knuckle line. So I can just try and get a better fit here to this this part of the stern of the vessel. So it can be a bit of backwards and forwards and iteration. The other thing I need to do is to get the keel rake in. What I'll do is first is I know this corner control point lies exactly on that marker, so I can select the marker and the control point, and then use snap control point to marker command to make them lie exactly on the same position. So now I can use the align to vector command for the control point, selecting the 2 extremes there, and then select all the intermediate ones. And then I can align those to a straight line, but I can also constrain it by holding the shift key down to the longitudinal position. So that will just move them vertically to be on that line. Now just tweak the stem profile a bit. And again I can use the align to vector command to get a smooth transition from the stem to the keel. So I don't want to change my keel, so the last selected point is the one that gets moved, and again I'm going to align that to the vector. It's not quite in the right position, so if I slide that point, I'll attempt to slide it along that vector. So I can just ensure they're on the straight line by selecting them again. Doing in the perspective view it's easier, so the last one is the one that will get moved, and just align that to the vector there so I get a nice smooth transition. Now moving to the body plan view, I'm going to turn on the markers just for the single section that's selected. I'm going to turn off the sections so I can just see one at a time, and also turn off the net. So now when I select a control point column, I see the section that's going to be most affected by that control point column and the markers for that section. So now it's just a question of iterating through moving just the interior control points to get them roughly in the correct place. And you have to sort of do it as a bit of an iterative process because of the longitudinal influence of the control points. So here I've sped everything up a little bit just so you can get an idea of how the fitting process works. It's a little bit more tricky in the stern there. We've got more of an S shape or an hourglass shape. And you can actually see there those compacted control points doing that knuckle in the transom. So again, just iterating through, starting from the beginning, working my way aft. You can, if you like, switch to the profile and plan views and try and ensure that the markers are all, the control points are all nicely aligned and smoothly aligned. So here I've turned on the net again so I can see all the control points and also the water lines. I can try and do some adjustment here to try and fit to those water lines. I'm just using the background image because I don't have markers on all my water lines. So I can see here I'm having a bit of difficulty getting a really good fit to these water lines, so I think what I'll have to do is add an extra control point column just to get a bit more control over the shape. So I'll do that by inserting a control point column there. And again, so I need to make up for that adjustment in shape by moving some of these control points around to try and get a bit of fit. So I don't want to just focus on the profile, on the plan view. The profile view is also handy just to check everything's smooth, and remembering that the NURB surface is always going to be smoother than the underlying control point net. So if I've got a nice regular smooth control point net, then my surface will be nice and smooth. So generally it's a good idea to try and keep your control point columns vertical, but obviously near the bow and stern where you've got a lot more shape, you quite often have to move them away from that vertical. If I keep the shift key down, then it's just going to move in the most orthogonal direction. So for most of these middle ones here, I'm just keeping the shift key down and just moving them up and down. So just a bit of smoothing out in this area here just to get a bit of a better shape here. Sometimes if you focus too much in the body plan view, you can end up with quite an irregular net, so it's good to work in all three views and just iterate one between the other. Don't do any too large a movement, and make good use of the shift key so that you're only changing the shape in the view that you're looking at. So I'm getting quite a good match here for the water lines, but again they're quite tricky. So I'm probably going to focus more on the body plan and the markers that I generated in the body plan. So I have another iteration through here, fitting the sections to the markers that I've got. So there seems to be, with this drawing, actually some slight discrepancy between the different views. So I'm going to take the body plan as the most accurate and work mainly off that one. So just speeding up the fitting process here a little bit. I think this probably took me about an hour overall, and this has all been compressed into maybe 15-20 minutes. So again, we're aiming for as smoother net as we can get, trying to get the right shape. So again, this is a bit of an approximation process because we're not sure exactly how accurate the drawing is, and again with the manually digitized points there's a bit of margin for error, so we're just looking for at the moment the best sort of approximation to the shape. So once we're reasonably happy with what we've got, we can have a look in the rendered view. That looks quite good. If we wanted, we could use a false colour rendering. We can also go to the markers table, and if I associate that with the hull surface, I just use fill down to do it for all the markers. I can actually measure the error from the marker to the closest point on the surface to that marker. So there you can see the maximum error was 28 millimeters and the average error. And this would be a good point now to go to the automated GA fitting to fit the rest of the interior more accurately. We'll now look at how we can use the genetic algorithm fitting to improve an initial manual fit. So with the manual fit we would have fitted the corners, the edges, and then done a rough fit of the interior of the surface. The GA fit can then be used to improve the fitting in the interior part of the model. And it works very well if the markers are not organised. So for example, if you just had an unstructured point cloud, which would be quite hard to fit manually if you didn't have section data. So here I'm starting with my initial model that I fitted manually and had quite a good fit for actually. And what I'm going to do is assign all the markers to that whole surface. And I can measure the marker error and I can see that I've got about 15.6 millimeters as the maximum with a mean error of about 4.2. So now what I'm going to do is actually duplicate this hull on exactly the same spot so I can compare the genetic algorithm fit with the initial hull that I started with and see how it's improved. So I'll just make a copy of that and I'm going to rename it the parent hull, and I'll also hide it so that it won't be used in the fitting. So from the markers menu I've got the fit surface to markers. I can select the surface I wish to use, which is the hull surface, and I can also specify the time that I want the algorithm to run for. I want to lock the edges because they've been fitted already, and this model has a bit of tumble home, so I'll untick that option. Then it's just a question of starting the fit and waiting for the time to elapse. During the fit you can see how long and how many generations have been tested. So the algorithm works by generating a large number of random models and then picking the best models and using them as a basis for the subsequent generation of models, and you should see the error gradually decreasing. So when it's finished I can accept and close the model, and I can see what the error is again and compare that to what I had before. So there's not much change, a slight improvement, but I think my original model was actually quite good. So if I want, I can actually go to the preferences menu and show the marker with the colour based on its error. And to highlight that a bit better I can make the markers a bit bolder by changing the thickness here. So if I change that to 3, the markers will be a bit brighter, and you can see that one red spot, and I actually think that's more of an error in the digitizing rather than an error in the modelling. So you can see we've got quite a smooth surface here with the different contours. And we can also look at the Gaussian or longitudinal and transverse curvatures and see. So you can see here we've got quite a smooth model. So if I just go back to the smooth shading, I can compare the original to my parent. So the new hull is yellow. I'm just going to change the colour of the parent to red. And if I turn that on, you can see the difference between the modified hull, the yellow one from the genetic algorithm, and the original red one. And there's another option to make the surface contours follow the same colour as the surface, and in that way I can also compare the contours of the two different models. So the yellow curve is the modified hull and the red is the parent. So now we'll see how we can fit a NURB surface patch to 4 edge curves. And there's 2 ways of doing this. We can either do that directly by fitting the NURB surface edges to selected markers, or we can fit the NURB surface to curves. So in the second case we want to first fit the curves to the markers and then generate the surface from those edge curves. And in both cases we can use the genetic algorithm fitting method for the interior if we need to improve that area of the surface. There are two ways that we can fit a surface by fitting its edges. The first, we can directly fit the surface edges to selected markers, and that's the one I'll show you first. So I've already actually prepared a surface with the number of control points and stiffness that I'm after. And if I select the markers that define the top edge, and a control point in that top edge, if I go to the markers menu, I've got fit edge to markers. First question asks if I want to leave the corners where they are, but in this case I actually want to move the corners, so I want to say no, and I can do a nearest neighbour search on the points. So there, that's fitted my deck edge. I can do something similar with the bottom edge. And again, I want to move the corner points and use nearest neighbour. And now I can fit the transom. So notice I haven't selected that last point because the control point's on there, so it makes it hard to select. And again, select the edge. Now I can do markers, fit edge to markers, and in this case the corner control points are already in the correct place, so I want to leave them where they are, and this time I'll use the selected order. And I can do the same for the stem profile. So again, I want to leave them where they are, and I'll use the selected order. So that's given me a fairly reasonable fit, so I might want to actually try and smooth out these control points a little bit. So let's see if we can, without changing the shape too much, just smooth those out a bit. The bottom ones look okay. Let's have a look at the transom. So hide the net, just see the transom ones, and you can see here it's these ones across here. There's a bit of a wiggle here which is a bit strange, so let's try and improve that a little bit. And again, we don't want this control point to be lower than that one, otherwise it will give me a hollow in the bottom. So that's a height of 0.351. Let's make that exactly the same height. And again, that's going to be quite a good fit. So my surface is going to look a little bit strange if I turn on the net, because I've got all these control points here. So we've actually got a tool here which is to smooth the interior control points. That's just going to do some interpolation. So I could turn on my sections, and it tends to maybe smooth everything out a little bit too much. So we could maybe use the genetic algorithm to get a better fit to those interior control points from this stage here. So that's the first method of directly fitting the surface to the markers. Alternatively, if I've got curves, I could generate a surface directly from those curves. So I've actually got some curves in here, so let me hide that surface. So let me turn on the curves. And so here I've got the 4 edge curves that are fitted to those markers. So if I select those 4 curves, the shift key down, and I've got a command to directly create a surface from those curves. So create a four-sided patch, and that will automatically generate that surface. And again, I could either use that directly, or if I wanted a better fit to these interior markers, I could use the genetic algorithm. So now we can look at the final method, which is basically skinning a surface through a number of section curves, or curves that define the cross-section of the surface shape we're after. So this requires the markers to be structured on sections in a similar way as we've been using to generate the tri-mesh. We then fit curves to those marker sections and then skin a surface through those curves. So now we're going to look at how we can skin a surface through a number of section curves. So as you can see here, I've already got my markers all sorted into sections, and then correctly on each section you can see the markers are connected with straight lines and the bold markers at the bottom of each section. So I can actually select all my markers, and in the curves menu I can fit curves to marker stations. And you can see here I've got generated 15 curves with the control points here. I can now lock those curves to make it easier to select. And then if I select each of those curves with the shift key held down, I need to select them in the longitudinal order. And now I can generate a surface by skinning through those curves. So I want to use the selection order, and I've got a few extra options here. So I know I probably want about a longitudinal stiffness of something like 6 and maybe 4 or 5 for the transverse one, and I'm going to increase the number of control point columns longitudinally. So that's actually given me a reasonably good fit to those curves, but unfortunately the net is maybe not quite as smooth as we would like. However, it then does depend what you want to do with that surface. If it's just to calculate hydrostatics, that may be sufficient. Delete that surface. So we can select all the curves again, go to the surface menu and skin through those curves. So we can see what happens if we give an exact fit. And we want to select by selection order, by longitudinal position. And you can see there, again, it gives a nice fit to the data, maybe a few too many control points to be really useful to modify. But it could easily be sufficient for calculating hydrostatics or doing other hydrodynamic performance analysis. An alternative method which directly fits a NURB surface through the markers if they are correctly sorted and ordered on sections is also available. This feature was formerly in the standalone program called Fitting, but now has been included directly in Modeler. So with the markers correctly sorted and ordered on the sections, we just need to go to the markers menu and choose Generate Surface, and this will work on all the markers or the selected markers. And here we have some options for the surface that we want to generate, the number of rows, the number of columns. So I might make this 7 columns long and 5 rows. The transverse stiffness I'm going to increase to 4, and the longitudinal stiffness to 6. We then can specify the convergence limits, specify a maximum error in millimeters. So I'm going to try and reduce this maybe to 1 millimeter, and we can also specify a maximum number of iterations. If the number of iterations is too large, it can start diverging, so maybe 30 would be plenty. We can also control where we want to space the control point columns. We can have an even spacing along the length of the vessel, or weighted towards the bow or stern, or weighted towards both ends. So I might use bow weighted because there's more curvature there in this vessel. Also, other constraints we can add, such as flat to bottom. This ensures the dead rise is never less than 0 degrees. flatter side, which means there's no tumble home. And this last option, the surface column, applies the weighting we've selected here, otherwise it'll be unconstrained. So all I need to do now is press OK, and it will have fitted the surface through those markers and given some statistics on the accuracy of the fit. I'd like to share with you some of the future developments that we're working towards at Bentley Systems. Context capture is a very interesting product. From a number of photographs, it can generate a triangulated mesh of a 3D object. So here I have an example of a sailing yacht that was in a marina in Hendaye in France, and I took about 150 photographs of one side of the hull. And then you can see on the screen the tessellated reconstruction that was created by context capture, and also the imported model in MAXSURF. And you can see we're able to calculate hydrostatics, for example the sectional area curve. It can be quite a lot of post-processing depending on the quality of your images, but it's certainly something that's possible at the moment. And we hope to be able to improve the interface from context capture to MAXSURF in the future. So thank you very much for listening, and any questions?